Tonight, you will lie down, close your eyes, and willingly lose contact with the world for about 8 hours. You will stop watching for danger, stop searching for food, and become almost completely defenseless. From an evolutionary point of view, that sounds like a terrible idea. And yet evolution has preserved sleep across an enormous range of animals. Octopuses show quiet and active sleep. Fruit flies sleep. Some birds can even sleep while flying. If sleep were only wasted time, natural selection has had hundreds of millions of years to remove it. It did not. The first surprise is that sleep is not one state, and it is definitely not the brain simply switching off. During a normal night, the brain cycles through non-REM sleep and REM sleep again and again. In deep non-REM sleep, large groups of neurons begin rising and falling together in slow electrical waves. In REM sleep, the brain becomes surprisingly active, the eyes move rapidly, and most muscles are temporarily held still. So the real question is not, why does the brain turn off? It is, why does the brain need these strange repeating states? One leading answer is memory. While you are awake, the hippocampus rapidly records pieces of what happened. But that fast storage system is limited. During sleep, patterns linked to recent experiences can reactivate. Researchers think this replay helps reorganize memories across wider cortical networks. Imagine learning a piano sequence in the evening. The next morning, you may perform it more smoothly without practicing during the night. Sleep is not a magic upload button, and scientists still debate exactly which memories are selected and how. But the evidence is strong that sleep supports learning and long-term memory in ways wakefulness alone does not fully replace. A second theory begins with a problem created by learning itself. Every day, useful experiences strengthen many synapses, but strengthening everything forever would become expensive and noisy. The synaptic homeostasis idea proposes that sleep turns the overall gain back down. Weaker or less useful connections may be reduced, while important patterns survive the reset. That could save energy, reduce noise, and leave the brain ready to learn again the next day. It is an elegant theory, but sleep biology is messier than one master reset, and different circuits do not all change in the same way. Then there is the theory that made sleep sound like a nightly washing machine for the brain. A famous mouse study reported that fluid movement and the removal of certain molecules increased during sleep. Later, human imaging showed slow brain waves, blood flow changes, and cerebrospinal fluid pulses moving together during non-REM sleep. The idea was irresistible. Perhaps sleep exists, partly so the brain can clear metabolic waste. But in 2024, another mouse experiment found that small dye molecules cleared more slowly during sleep and anesthesia than during wakefulness. Researchers then argued about tracers, pressure, anesthesia, measurement methods, and what clearance should actually mean. So the brain cleaning story may contain something important, but the simple version is not settled science. Sleep is not only for the brain, it changes hormones, metabolism, cardiovascular activity, temperature, and immune signaling. Sleep and immunity communicate in both directions. Infection changes sleep, and sleep changes immune responses. Restrict sleep repeatedly, and attention, mood, glucose regulation, appetite, and cardiovascular health can all suffer. That does not prove one single purpose. It shows that sleep is woven into many maintenance systems at once. Animals reveal just how necessary sleep seems to be, because evolution has modified it instead of eliminating it. Dolphins and some birds can put one brain hemisphere into slow-wave sleep while the other remains more alert. Frigate birds have even been recorded sleeping in flight, usually in very short bouts, while circling on rising air. Nesting chinstrap penguins can accumulate sleep through thousands of microsleeps, lasting only seconds. These are not animals that escaped sleep. They are animals forced to negotiate with it. The easiest thing to prove is not why sleep exists, but what begins to fail when sleep is removed. After too little sleep, reaction time slows, attention becomes unstable, and the brain can slip into microsleeps lasting only seconds. A person may look awake while parts of the brain behave as though they are already asleep. That is why severe tiredness can become dangerous while driving or operating machinery. Recovery sleep helps, but one long night does not always instantly reverse every effect of repeated restriction. So why do we sleep? The most honest answer is probably not one sentence. Sleep appears to support memory, recalibrate neural connections, coordinate body maintenance, and perhaps change how waste moves through the brain. But scientists still do not agree on one primary function that explains every stage, every species, and every consequence. Maybe sleep is not a single repair job. Maybe it is the biological condition that allows many different repair jobs to happen together. You spend roughly a third of your life asleep, not because biology gave up on those hours, but because biology is using them. And tonight, when your eyes close, one of the oldest unsolved experiments in nature will begin again.